Today's lesson, section 3.5a, we're talking about complex numbers. Now, a complex number is an expression of the form a plus bi, where a and b are real numbers, and then I squared is actually equal to -1, which means that when you just have I, that represents the square root of -1. Okay, so here we're wanting to be able to perform the operations of addition, subtraction, multiplication, division when you're adding or like dealing with two complex numbers at the same time. So addition and subtraction is really just putting like terms together. Multiplication is kind of set up as two binomials, so you'll have to use FOIL to be able to deal with it first and then like terms. And then for division, what we need to do is actually multiply top and bottom by what we call is a complex conjugate. And we'll talk about when we get there. So letter A, basically, if there's nothing going on, we can drop the parentheses and then we can group our numbers that are like together. So we would say 3 and 4, which are real numbers, together. That gets us 7, and then 5i and 2i get together and subtract to get you 3i. Okay, for letter B, when we're talking about subtraction, it's really only difference is I need to multiply a -1 through first before I drop my parentheses. And then from there, it's very similar to letter A for addition, putting like terms together there. So then I get the following value of -1 plus 7i. Multiplication has a few more steps here where I need to take the first numbers, multiply, outside, inside, last. Now when you do multiplication, you're going to get a new term called I squared, and because you have I squared, like it said in the definition, is actually equal to -1, because square root of -1 times the square root of -1 is actually -1. Okay, kind of like if you have square root of 2 times square root of 2, that gets you 2. So then from there, once you do that, you're able to put like terms together, because 12 and 10 are now like terms, and then I'm able to get the answer of 22 and 14i. For letter D, here we have division, and notice that in the denominator we have 4 minus 2i. This is like having a radical in the denominator, so what we need to do is rationalize it by multiplying top and bottom by the complex conjugate. So since we have 4 minus 2i, I need to multiply both top and bottom by the opposite. So the middle sign will change, nothing else. So that would be 4 plus 2i. And then from there, I would just use my skills from multiplication to do the top and the bottom. Notice that here you have an I squared on the top and on the bottom because of the multiplication. And then from there, that just means that you're going to have a -1 in place of those, which makes them like terms with the number that you started with. So the 12 and the 16 have a like term now. So in the numerator, 12 minus 10 becomes 2. 16 plus 4 becomes 20. And then you get to divide. So essentially, anytime you have an I squared, the sign that is attached to that I squared before the coefficient will change to the opposite sign because it's just -1. Okay? For this part, we're talking about square roots with negative numbers. If I have a negative value underneath the radical, that means it's really just like square root of -1 times the square root of r, which is the start here. And then you can separate them, and that makes I for the square root of -1. So like for letter A, you had a -1 and a 16. That gave you 4i. For letter B, sometimes you have multiple of these in your problem because we're going to have to multiply two binomials essentially. So first I multiply everything out. And then from there, I can simplify my radicals. So I'm looking for perfect squares. I can also look for these -1s that I can pull out to make i's. So in the first one, there's a square root of 4 and 12. So I can make that a 2, and that leaves me with square root of 3. In the second one, -4 can be separated into -1 and 4. 12 can be 4 and 3. So there I can pull out two 2's from that radical, and then an I as well. That leaves me with square root of 3. And then the next one, I have a -1 and a 3, so I can just pull out an I. That leaves me with square root of 3 there. And then from there, the last one, I have two -1s that I can pull out, and a 3 and a 4, which 4 becomes 2. then I have an I squared because I have two i's that are multiplied to each other. So simplifying, I get 6 squared root of 3, 4i squared root of 3 minus 3i squared root of 3, and then because that I squared becomes -1, it's actually positive 2 squared root of 3. And so here I actually have two sets of like terms, because remember square root of 3 is kind of like an x. So because of that, I could put my like terms together. It gets me the following value. And here you can actually write it in two different ways, because you could factor out the square root of 3 if you'd like, but you don't have to. Okay? Thanks for watching.